I graded the exams, at least the ones that have been done so far. And there were 13 A's, 5 B's, and 1 C. But if you have any questions on it, let me know. Those who have not taken it yet, I think there's a couple people that haven't set up a day to make it up. So please get with me. We don't want to get behind because the next exam is Monday, July 31st, over chapters 7, 8, and 9. It sounds like a lot, but it's a lot less than the last one. Because we only cover 2 sections in 7, 1 in 8, and 1.5 in 9. Any questions? Okay. There were 2 problems I wanted to go over in section 7.1, and then we'll start 7.2. Number 53, if the price in dollars of a stereo system is given by P of Q equals 1,000 divided by Q squared plus 1,000, where Q represents the demand of the product, find the marginal revenue when demand is 10. Marginal revenue, marginal means derivative of the revenue, which we don't have revenue. Remember, revenue is price times quantity. And we do have the price. That's our P of Q. So that's our price, and quantity is Q. Any questions on that? We did not learn the product rule yet, so in order to take the derivative, we would need to distribute. When you multiply the Q here, this cancels with one of these and leaves 1,000 over Q plus 1,000 Q. This would be our revenue function. Marginal revenue means to take the derivative of it. In order to take the derivative, this Q in the bottom needs moved up. Any questions? So this is our revenue function. Marginal means to take the derivative of it. And right here, it said marginal, oops. Taking the derivative, -1 times 1,000, -1,000 Q, and then we're subtracting 1, so it would be a -2 in the exponent. This is a 1 times 1,000 is 1,000. Subtracting 1, we get Q to the 0, which drops off. So that would be your marginal revenue. Any questions on that? And we wanted it at 10. Any questions on that? What that's telling you is you're already producing or selling 10 of them. I guess it would just be selling because it's revenue. You're selling 10 of them. If you sell one more, it'll increase the revenue by 1,010. So it's telling you how it would change if you want one more. That's what your derivative tells you. So we're selling 10. The 11th one will bring us a revenue of $1,010. And in the next chapter, we talk more about that. Any questions on it? $54. Suppose that for the situation in 53, so what we're using is this revenue equation. Well, we could use the one where we brought it up. Let me move that out of there. We'll use this one. The cost in dollars of producing Q stereo systems is given by this. Find marginal profit. So in this case, we're finding, again, marginal derivative, but for the profit function. To find the profit function, remember profit. I'll use Q's since we have Q's. Profit is revenue minus cost. Our revenue function is this. That was our revenue. Then we need to subtract the cost, which was given here in the problem. What you want to remember is you have to subtract the whole function so that negative distributes to each term. Negative 0.2 Q squared. And then this will combine with this one. 1,000. This negative has to distribute. 1,000 minus 6, 994. I put them in order by the exponents. They didn't have to be, they could have been in any order. So this is our profit function. Marginal profit. You take the derivative. Go ahead and take the derivative. On my math lab, be careful, make sure this is solved for P. Sometimes number 51. It was solved for Q, so you'd have to solve for P first. And then follow the same steps as we did for 53 and 54. So you do want to make sure that when you go to find revenue, it's solved for P. Derivative negative 0.4 Q to the first. This is a 1, so positive 994. Q to the 0 drops. This is a constant, so it goes to 0. And then negative 1000 Q, subtracting 1, negative 2. Any questions on the derivative? And they wanted us to find marginal revenue at 10. So just plug a 10 in. Any questions on that? So we're selling 10 of them. If we produce and sell the 11th one, we make a profit of $980. So the 11th stereo will bring us a profit of $980. Any questions on that? Section 7.2 adds 2 more rules. One's a product rule, one's a quotient rule. Product rule is when 2 things are multiplied together. So if we had two parts multiplied together, then the derivative is u of x times the derivative plus the derivative of the first times the second. Now, because you're adding, it doesn't matter which one you take the derivative of first. Another way of remembering it is look at first and second. When you take the derivative, it's first times the derivative of the second plus the second times the derivative of the first. Rather than trying to remember u of x times v prime of x plus u prime of x plus times v prime of x, it's a lot easier to remember words. So first times the derivative of the second plus the second times the derivative of the first. Now you can have a formula sheet for the test. So you could have these written down. If we look at this and we want to use the product rule. This is our first. And this is our second. First times the derivative of the second plus the second times the derivative of the first. Write the first. 3x squared plus 2 times the derivative of the second. What's the derivative of 2x minus 1? Should get 2. So you want to be able to do these quickly, but the derivative of 2x minus 1 is just 2. This is a 1. 1 times 2 is 2. X is 0 drops out, and the constant is 0. Plus the second times the derivative of the first. 6x to the first, 2 goes to 0. These basic ones, my math lab will probably want you to multiply out and combine like terms by distributing your 2 and your 6x. And then combine. On a test, I would be fine with this because then we'd be plugging values in, and if you want to probably plug them in here, that's fine. Or you can simplify and then plug in. Any questions? Let's try number 2. So anytime you have parts multiplied together, quantities, you can use this. So we took the first 5x squared minus 1 times the derivative of the second, which is just 4. Plus the second, 4x plus 3 times the derivative of the first, which was 10x. Any questions? You could FOIL it. 20x squared minus 4 plus 40x squared plus 30x. Combining like terms. Any questions? No, there is what's called a chain rule, but we don't go into that section. So remember when we did this before, we multiplied them together or FOILed them? So it would be 2x minus 5 times 2x minus 5. Go ahead and take the derivative. First times the derivative of the second, which is just 2. Second times the derivative of the first, which is also 2. And then you can distribute. 4x minus 10 plus 4x minus 2. Combining like terms, 8x minus 12. Any questions on that? Go ahead and try number 7. Oh, notice there's a square root and we don't have a derivative for a square root. We have to rewrite it as an exponent. Square root would be exponent 1/2. And so that's why I rewrote it. First derivative of the second, 1/2 x to the negative 1/2 plus second times the derivative of the first, which is just 1. This is one where you may not want to simplify it. But my math lab might make you do that, but on the test you wouldn't have to. Oh, let's see. 1/2 x. Now remember, you're adding exponents. This is 1 plus a negative 1/2 is a positive 1/2. Times 1 is 1/2 x to the negative 1/2. Multiplying by 1. These two are like terms. 1/2 plus 1 is 3/2. X to the 1/2 plus 1/2 x to the negative 1/2 plus 2. Any questions on that? Number 9. Go ahead and find the derivative if you haven't already. First times the derivative of the second. Negative 6y to the negative 4 plus 20y to the negative 5. And I'm going to run out of room. Plus the second times the derivative of the first, which is a negative y to the negative 2 minus 2y to the negative 3. Any questions on that? I would not go any further. What I find is taking the derivative, everything's correct, but then when you try to FOIL all of that, that's where I find a lot of mistakes. So I would not go any further. Any questions on that one? If you're looking ahead, the next group is division. That's our quotient rule. I use top and bottom to remember it, and I use a T for top and a B for bottom. When you take the derivative, it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. Now, in this case, which order you do first does matter because of the subtraction. Remember, the bottom, when you bring them up, gives you negative exponents. That's what's causing that minus. So the derivative of the bottom is the one that's subtracted. Let's try number 11. bottom times the derivative of the top. So we write the bottom times the derivative of the top. Derivative of the top, just 6. Minus the top times the derivative of the bottom, which is just 3, all over the bottom squared. And you can leave the bottom squared. You don't need to multiply that out. From your test, you don't have to reduce the top either. You can just plug in if you want. On MyMathLab, if they just want the derivative, for the most part, they want that top simplified. And it usually simplifies pretty nice, so it's a lot less to type in also. But leave the bottom factored. Six times 3, 18x plus 60. Now here I'm distributing a -3. -3 times 6, -18x. -3 times 1, -3. Over the bottom squared. Notice the 18x's cancel. And we have a positive 57. On top. This is a lot nicer to type in than to have to type this. And it usually simplifies pretty nice. Maybe not always to a number, but any questions? Let's try number 16. Bottom x plus 3 times the derivative of the top, 2x minus 4 minus the top times the derivative of the bottom. For the derivative of the bottom, did everyone get a 1? All over the bottom squared. Simplifying this one, you would have to FOIL. Here you're distributing on the second part a -1. FOILing. First, 2x squared minus 4x plus 6x minus 12. Squared minus 4. Distributing the negative x squared plus 4x. All over x plus 3 squared. The x squareds, leave an x squared. The two 4 x's will cancel and leave a plus 6x minus 12. Any questions on that? On a test, any one of these would be fine, and then just plug your value in. Let's see, 19. Go ahead and try number 19. Bottom times the derivative of the top, which is 2x minus 4, minus the top times the derivative of the bottom, which is 2x, all over the bottom squared. Any questions? Let's try one more, number 21. And I would rewrite that radical t to the 1/2 t minus 1. And go ahead and take the derivative. Any questions on that? This one's like terms combine, but you could leave it like this if we distributed it though. 1/2 t, adding the exponent 1 minus 1/2 makes this a positive 1/2, minus 1/2 t to the negative 1/2, minus t to the 1/2, all over t minus 1 squared. These two can be combined. 1/2 minus 1 is a negative 1/2 t to the 1/2 minus 1/2 t to the negative 1/2 divided by t minus 1 squared. So I don't know that it's that much better, but any questions? So on the test, any one of these would be fine. And then plug into it. Any questions? One more, number 27. Notice that it has division, but it also has multiplication. It's kind of throwing everything together. So if you're comfortable with that one, you're fine with these. 27, yeah, we'll do 27. Doesn't really matter. 27, 28 are the same. Now when you're doing these, if you have that division bar like we have, you do that first. So then when you take the derivative of the top, it has a product rule. But that division bar comes first. On the test, I do not have one that has both in it at once. We're going to do top and bottom first. And when we do the top, we'll have a product rule first and second. Bottom times the derivative of the top. The derivative of the top, there's a product. First times the derivative of the second plus the second times the derivative of the first, which is 6x. Bottom derivative of the top minus the top times the derivative of the bottom, which is 5. All over the bottom squared. So there are cases where you need to find both or combine things. Now you could, since we don't have certain rules like the chain rule where there's an exponent, you could FOIL this first and then you just have a quotient rule. Any questions on it? Okay, one uses one uses the other. All right, let's look at 33. Find an equation of the line tangent to the graph at the point 3, 3. There's definitely one of these on the exam, and it's either similar to 33 or 34. Notice they gave us the entire point where last class we had to also find the point. So to find the tangent line, you need a point, which they gave us. We need the slope, which is your derivative, and then we can find the equation. So we have the point. Remember, the slope is your derivative. This is a quotient, so we need to use our quotient rule. Go ahead and take the derivative. We did bottom times the derivative of the top is just 1, minus the top times the derivative of bottom is also 1, all over the bottom squared. I'm going to simplify this one, but you could plug your 3 in here. You don't have to. But this one simplifies nice. X minus 2 minus x. The x's cancel, and our slope is negative 2 over x minus 2 squared. Any questions? We want to find when x is 3, so we plug in a 3. And we get negative 2. So now we have a slope and we have a point. Any questions? Y minus 3 equals negative 2 times x minus 3. Distribute your negative 2 and bring your 3 over. Everyone get y equals the negative 2x plus 9. Any questions? Okay, try number 34, except notice that's a product rule. And on the test, I will say using the product rule. That way you have to, you can't just FOIL it. This one you wouldn't be able to simplify, you'd have to use the quotient rule. This one you could FOIL, but I will say using the product rule. Again, they gave us the point. So we need to find the slope and then we can get the equation. first times the derivative of the second should just be a 1, plus the second times the derivative of the first. Distributing, you could just plug in there. Or you can distribute. Let's do this one plugging in here just so you can see. 2 times 1 minus 1 times that one plus 1 plus 4 times 2. 2 minus 1 is 1 times 1. This whole thing is just 1. Here we have 5 times 2, which is 10. Our slope is 11. So you don't have to FOIL it. You can just plug in. It's up to you. You can distribute the 1, distribute the 2, combine like terms, and then plug it in. Either way. We have a slope, we have a point. Y minus y1 equals m times x minus x1. Y minus 5 equals 11 times x minus. Distribute the 11. 11x minus 11, and then add the 5. There you go. So this line will touch the graph at 1 point, and that point is 1, 5. Any questions on that?
Could you show it to where like you would simplify basically like 2x minus 1 times 1?
So if I was going to simplify, I'd distribute the 1 first. So 1 times 2x is 2x. 1 times a negative 1's a negative 1. And then here we would distribute the 2. 2 would give us 2x plus 8. And combine like terms. 4x plus 7. And then plug your 1 in. Is that what you meant?
Yes, thank you.
You're welcome. Yeah, I think that this is a little easier. But depending on what you have here, when you take your derivative, if it's one of the more complicated ones, it's probably easier to plug in. But I think you're less likely to make a mistake on this one. Any questions? Number, they're similar. There's one like 43 or 44 on the test. Let's do 43, but then we could do both if you need to. The total cost in hundreds of dollars to produce X units of perfume. I always try and write, especially when it's not just dollars, so I remember. Find the average cost for each production level and then find marginal average cost. They actually should put C first, because if you find C first, then you just plug the numbers in. Now remember, average cost, we divide by X. Um, but notice if we divide this by X, we have a fraction within a fraction. Another thing you could do, because remember, dividing by something is the same as multiplying by its reciprocal. So when you have this fraction, you could multiply by 1 over X. Because dividing by a number is the same as multiplying by its reciprocal. Instead of then dividing this whole thing by X, we can multiply by 1 over X. Any questions on that? So if you have a fraction and you have to find the average of the function, it's easier to multiply by 1 over X. So the one on top does change. 3x plus 2, still 3x plus 2. But on the bottom, distributing the x, we have x squared plus 4x. This is the average cost function. Any questions on that? This would be part C. Part A wants 10 units, so you just plug in 10. Are you getting? Now remember, cost is in hundreds. So if we multiply this by 100, it's 2286. If we want 10 books produced, these were books, or units of perfume. If we want 10 units of perfume produced, they'll cost $22.86 each. Because this is average cost, so it's the cost per item. And it was in hundreds, so that's why I multiply by 100. second one, or B, wants us to plug in 30. And you plug in 30. And it was in hundreds, so we multiply by 100. If we produce 30 at a time, we get them for $9.02 each. Any questions on that? Marginal average cost. Marginal means take the derivative, and they want the derivative of average cost. So we're taking the derivative of this one. Bottom times the derivative of the top, which is just 3, minus the top times the derivative of the bottom, 2x plus 4, all over the bottom squared. Any questions on that? Chapter 8. We only cover 8.2. And some of the story problems we've been doing, it's just what it covers. 8.2. 8.2 works with critical numbers. And the critical numbers are the numbers in the domain of f of x, where the derivative equals 0. Or where C does not exist. Now, most of these, they'll give us an interval that we're going to be using. When it has parentheses, that means you don't include the endpoints. There are some cases with max and min where we will include the endpoints. The reason the critical numbers are important, remember when I said if we take the derivative and set it equal to 0, that's where the tangent line is horizontal. Well, that's where all our highs and lows are on the graph then. The relative max and the relative min occur at the critical numbers. and if there's endpoints. We have a relative max, and these drawings are if we were looking at a graph. We have a relative max if the graph is going up and then down. This would be a max. But it could also be at an endpoint. To be at an endpoint, if this was A, this one would be coming down. So we don't know what's happening here. It could even be going up, but since we're stopping there, that can be a max because it's above the line next to it. So your max is when the lines to the right and the left are below it. When it's an endpoint, it only has the one, and if it's below, then it's a relative max. They're calling it relative max because it might not be the highest value, but it's a high value. The points around it are all below it. Now that could also happen with B. For B to be a max, this line would be going down. This is where your A would be. This is where your B would be. And if they are, if the values next to it are going below it, then it's a max. A relative min, if it's in between A and B, would be going down and then up. This would be a min because it's a low point in the values around it. Or if it was the endpoints, we look at where A would be. It needs to be the low value, so from here it will be going up. For B, it would be coming down. So then the points around it are above it. So an endpoint can be a max or a min. Even though we don't know what's happening on the other side of it, we only look at what we can see. And this would be a high point, this would be a low point. Any questions? Problems. 549. These all look about the same. Okay, we'll do number 4. Oh, what's it asking? So find the locations of the values of all relative extrema. Extrema means both max and min they want us to find. For the functions below 1 through 8. So these first couple are all pretty much the same. So we'll do number 4. Now if we look at number 4, we want to find any max or min. These arrows keep going, so there is no endpoints to look at. But this point here, this is a low point. Three, negative, looks like -4. So 3, -4. There's a relative extrema. Notice it's a low point. The points around it are above it, so it's a min. Relative min of, and then you put your y value at your x value, which is 3. So we have a relative min of -4 at 3. Find one that has more than 1. Number 5. So you're looking for your highs and your lows. Now, again, this one, we don't have to worry about the endpoints because there's an arrow. But we do have one high value and one low value. The 1 point -4, 3. And that's a high point, so that's a max. I'm going to put max right above it so we know. And then the other one, -2, 1. That's a low point. Now notice neither one is the lowest or the highest because this keeps going. But they are high and low points on the graph. So we said the -4, 3 is a max. A relative max of 3 at -4. And this one was a min, so there's a relative min of 1 at -2. Any questions on that? Okay, go ahead and try number 8. Okay. You find the points -3, 0, and 3, 0, and those are low values. And then the max 0, 4. When you have two max or mins where the y values are the same, you can combine them. There's a relative min of 0 at -3 and 3. And my math labs will even have you do that. They'll say, forget how they say it, separate them by commas. I think that's the hint to let you know that there could be more than one at that. So when they're both at the same y value, you can list them together. And this one was a max. There's a relative max of 4 at 0. Any questions on that? Okay, number 13. Find the x value of the points where the function defined as follows have any relative extrema. So we look at number 13. We know this is a parabola. And we know it's going up. So the relative extrema would be the vertex, and we've learned lots of ways of finding the vertex. Well, now that you know the derivative, another way of finding it is taking the derivative and set it equal to 0, because that's a critical number, and your vertex is a critical number. So we would take the derivative, 2x minus 10, and set it equal to 0. That gets our critical number. And it's also the x value for the vertex. Bring the 10 over, divide by 2. So there is a relative min at x equals 5. Find the y value, plug it back in, just like we did for the vertex. So this vertex is at the point 5, 8. We know it's going up, so this is a min. Relative min of 8 at 5. Any questions? Now let's try 17. Now it looks bad, but when you take the derivative, it comes out nice. This is a cubic graph. Well, let's find the points first, and then I'll show you. So the first thing I want to do is find the critical values. To find your critical values, you take the derivative, you set it equal to 0. We haven't worried about ones that don't exist, because with a polynomial, you don't have to worry about that. You only have to worry about it when you have fractions. By fractions, I mean the x's in the denominator. So we take our derivative. 3 times negative 4/3 is a negative 4x squared. Multiplying by 2, the 2's cancel and leave negative 21x minus 5. It is factorable. But I would use the quadratic formula. Because we're going to set this equal to 0. Yeah, I wouldn't. negative b plus or minus the square root. Not why I wrote that so hard. Minus 4 times a times c all over 2 times a. $361 is 19, the square root of it. And get negative 5. And negative 1/4. Any questions on that? And we need to decide if those are max or mins. Well, you could graph it if you wanted to go on Desmos and graph it. But this is a cubic. And this is negative. Cubic graph looks like a snake. Negative means it's going down. So if you think of your number line, the smallest value is going to be a min. This is going to hit at negative 5, and this is going to hit at a negative 1/4. So this one's going to give us a min, and this one's going to give us a max. So if you are comfortable with your graphs, you can see it just by the graph. Or you can graph it and you'll also see it either way. And to find the y values, we plug it into the equation. You know what, let's graph it. So then, let's see. You want to plug in the original. Okay, so there's our graph. We should be able to, there we go. It gives us our high and our low. Notice the negative 5. So we have a relative min, because at the -5, it's a low value. Of -62.83 at -5. And we have a relative max up here. That one is not the vertex thing, it's the -1. So you want to be careful. Notice there was 3 things there. We wanted the -0.25 because we had -1/4. Relative max of 8.615 at -1/4. But that, you can always enter your graph so you can see if it's a max or a min. Any questions on that? Any questions? Number 19. So to find the critical numbers, you take the derivative and you set it equal to 0. Four x cubed minus 36x. Set it equal to 0 and solve. Cannot use quadratic formula, that's cube. But we can pull a 4x out. And then we're left with x squared minus 9. And this factors, or you can use the square root method, but it does factor. Because it's the difference of squares. So this one has 3 critical numbers. Set each part equal to 0. Divide by 4 and get 0, add that over, and subtract. So we have 3 critical values, 0, 3, and -3. An even power resembles a parabola. So that means it's positive, it's going up. So -3 and 3, these should be relative low points or mins. And 0 should be a max. You can plug these into the original, so always go to where the derivative is, and the one before that, that's the one you plug into. You can plug it in here, or we could graph it. Since we graph the other one, we'll plug in, oh, I guess we'll graph it. Y equals x to the 4th Whoops, oh, I put 18 minus 4. Um, Oh my. You could also. That's not helping. We know we want 3, -3, and 0. Notice these two are at the same value. And their low points, we said it was a min. Relative min of -85 at 3 and -3. The other one is a max. Relative max of -4 at 0. Now, yes, you could just put the graph in and find the critical numbers, but I will specify find the critical numbers by using the derivative. So you do need to be able to take the derivative, set it equal to 0, and solve. But for finding the y value, if you don't want to plug it into the original, you can use the graph. Just make sure you're using the original. Otherwise, you'll get all zeros. Any questions on that? Any questions? Okay, number 27. This one is a fraction. And because there's that fraction, anything that gives us 0 in the denominator needs to be omitted. So the function does not exist here. That means that's a critical number. So one of our critical numbers is 3. You need to be careful of that. Most of the time, the values we're looking for are not from that value, but that is a critical spot. So you do need to know that. To find any other critical numbers, we take the derivative and set it equal to 0. Bottom times the derivative of the top, 2x minus 2 minus the top, times the derivative of the bottom, which is just 1, all over the bottom, squared. Any questions on that part? Okay, we will need to simplify since we have to set it equal to 0 and solve. So the top part I'd FOIL. First would be 2x squared minus 2x minus 6x plus 6. And then this one, we're distributing a -1. So it's just gonna change our signs, negative x squared plus 2x minus 1. Combining like terms, we have x squared minus 6x plus 5. Now, when you have a fraction and you're setting it equal to 0, the only way it can be 0 is if the top equals 0. So you could just set the top equal to 0. Now, the reason you can do that, this denominator, we can multiply both sides by it. Notice it cancels here and leaves the top. And 0 times anything is 0. So we're just setting the top equal to 0. Anytime you have a fraction, you want to set it equal to 0, you just got to use the top. Because the denominator cannot be 0. And you just think of it as that or multiply to the other side. This will factor -1 times the -5. When I multiply, I get the +5. When I add, I get the -6. But you could also use the quadratic formula, setting them each equal to 0. X is 1. And so critical numbers are 1, 5, and 3. But 3 is not one we could plug in because it would give us 0 in the denominator. Any questions on that? We'll graph it real quick. Y equals, remember, see where your derivative is and graph the one before it. X squared. Oh, it's not typing, darn it. Notice right here is where the, let me change my units. So you can see a little better. This is where our 3 is. From the right, it's going to positive infinity. From the left, it's going to negative infinity. But it is a critical value. Now, these two, the relative, this would be a relative min because everything is below it. Well, sorry, this one's a max and this one's a min. But you're not going to find your y values without plugging in. Oh, we can find the one, but we can't find the other one. But is there any questions on that? So this one's a max right here. These are going down. And this one, 5, oh, it does show the 5 is a min. Any questions? Okay, if you do not have any questions, I will see you tomorrow.
Hi, I had a question regarding the project.
Okay,
So it's regarding the best line in the R square. For my linear, I got 0.8016. In my quadratic, I got 0.802. And I was wondering if linear was rounded to the hundredth, which would be 802, the same as the quadratic. If I should just say they are equal, or if I should make the quadratic the best fit.
that's up to you. I would be fine with either one. If you do want to round to that and show that they are the same. They're both just as strong. Or if you
Yeah.
want to make one stronger, but that's fine either way.
All right. Thank
I
you
think
for your
that's
help.
kind of interesting that they came out.
Yeah, I
So
did
I
too.
think I like that.
Yeah, me too. Well, thank you very much for your help.
You're welcome.
Have a good day.
You too.